Welcome to the Convince tutorials. We start by checking out this overview repository. If you then navigate to the folder tutorials, there's a README file inside. This looks like this. And the purpose of this first video would be to give you an overview of how to run the tutorials and how to run the required Docker containers and what the tutorials are based on. First of all, it is necessary for you to install Docker and especially also be able to use Docker Compose. So please follow the official Docker installation instructions depending on your operating system. When you have this, you can then, if you are in this checked out repository folder overview, you can run docker compose pull, and this will pull the latest image of this tutorial. This may take longer on your machine. If you then run the command docker compose run base ROS2 run tutorial _sim run, you should see a window that contains the simulation. In the simulation, you can see that down here, this is the robot that we control, and we have 3 different rooms: a dining room, a kitchen, and a hall, and we have these corridors that connect them. And in these rooms there are different locations, for example a table, and this one is a fridge, and 2 more tables in the dining room. If we now want the robot to navigate, for example, to the kitchen table, we must type kitchen _table in this goal query field, and then press the navigate button, and then you can see that the robot has planned a path and moves to this location. If you look at the buttons up here, you can see that there are now some more buttons that are not gray anymore. For example, the button pick and the button close. If you want to pick something, we can, for example, take this item called soda zero, type its name up here in the Go query field, again press pick, and the robot is now holding this object, and we can now, if we want to, for example, bring it to this side table and dining room, we type side table in here, press navigate, and the robot is moving there. Be aware that all of these actions may be fail probabilistically. So for example, if we now want to place the object on the table, this was successful, but in the simulation we simulate failures simply probabilistically, so it maybe happens in your experience that one of these actions is not executed immediately. You would see this then written in the terminal over here, and then you could simply try it again. But ultimately, of course, we want to make this example an autonomous robot, so we need a system that controls the robot, and for this we provide behavior trees that can control the robot. If you look again in the tutorials folder, in the ROML folder, and then in the policy folder, you can see 3 different XML files that each represent a behavior tree. If we start with this bottom one, bt3.xml, we can have a look at this graphically by running this command. So we run docker compose run base root and then -f, and then the path convince workspace source tutorials ROML policy bt3 xml. This will start the graphical editor GRUD, and this is expected that you get these warnings here first, because the GRUD does not know all the different nodes we are using, so you have to click OK on all of these windows. And if you are done, GRUD will show the behavior tree. We can now quickly have a look what this does. we can see under the root of the tree there's a sequence node, and the sequence node means it will in sequence execute all of these nodes that are its children. So the first one is navigate to location, and here you can see that we have the location fridge. So similarly to how we type the location into the field when we manually navigate it, this will now navigate the robot to the fridge. After that, you can see this node detect object. This is one that we did not use, but the robot has the capability to detect objects that it is currently not aware of. And as I said before, this action also may fail with a given probability. So it is in the tree under a decorator node that simply will retry this action in case it is not successful, and in this case it will retry it 3 times. After that, again retrying 3 times in case it's not successful, we will try to pick this object, and this now depends on the object that was detected here. So we don't yet know what is in the fridge, but whatever we detect here will be picked here, and again in case it fails it will be retried. And then we navigate to the location called table, similarly to how we just did it in the simulation manually, and there we again will retry and try successful to place the object. In this case, this is a generic node that calls a ROS action, but the behavior is the same as for the other 2 action nodes. We can now close this window again. In order to actually execute this tree, you have to use the command down here, where you again call docker compose run base, and then you call ROS to launch. So you run a launch file. This launch file is called full simulation, and you can give as a parameter this policy parameter, and then you just give the file name of the tree you want to execute. And if we start this now with this bttree.xml that we just looked at, this command will also launch the simulation for us. I can move the simulation a little bit to the side, and in this window you can then still see what the tree is doing. So you can see, for example, that the sequence node was first idle and was then running. Let me scroll up a bit. The sequence node was first idle and was then running, and was then basically executing the first child, which was the navigation node. And apparently this navigation was also successful, as we can see here. Then the detect object node was running, and also of course its decorator retry node was triggered. But then you can see here that after this was successful, the robot obviously tried to pick the object, as we've seen in the behavior tree, which then failed. Here you can also see that this was basically the simulator simulating probabilistically that this action now failed. And we can now see how our tree reacted. Our tree tried it again. You can see here it ticked the pick object node again, which was then successful. So its parent decorator node was also successful. And then in the sequence, the next thing would be to place the object. Here we can see, before that it was of course navigating to the table, which was also successful. And then it will try to place the object. And here you can see that it basically simulated another failure here, where it simulated a failure to place the object, which was then also communicated to the behavior tree. But then there was another failure simulated, so the second retry also didn't work. But in the last try, the place was successful, and so in the end the whole tree was successful, even though we couldn't really see it because it closed so quickly. But in this node, in this log, you can basically always see what happens. Feel free to now also try the other trees. So for example, there is this tree, bttree locations. You can also look at it in the XML format, which is the same information, but just not as visual. Here it will basically cycle through different locations and will then at all of these locations try to detect an object, and if it found an object, it will try to pick it. But you will learn more about this behavior tree in the following tutorials. Generally, you can look at this documentation also from the website Convince Project GitHub.io overview. So you will start on this landing page. If you then click on this introduction on the left, this is the documentation that we just followed through. And after you have successfully followed these instructions, you can then choose the other tutorials here on the left. Be aware that they may change over time as well as we add more of them. But for example, a good place to start would be the offline verification tutorial, where you will then again explore the different behavior trees and the different worlds that are available, and see how errors or problems in these behavior trees can be detected by offline verification. So have fun. In case there are any questions, feel always free to reach out to the Convince team. Have fun.